Module 4 Interpretations of Simplex Solutions. We will use examples that have been used in the previous module. In this example, the company produced 3 products and facing 3 resource constraints. The sources are labor hour, machine hour, and raw material. This is the final simplex table for the problem. We will use this to answer the questions. Why we said that the above table is the optimal table? We will check all the values at the C minus Z row. Since all C minus Z row values are less and equal to 0, we said that the table is optimal. State and interpret the optimal solutions. The company produced 3 products and facing 3 resource constraints. So in the optimal solution, we need to state the production value of all products and total unused resource for each resource. X1, X2, X3 for product, S1, S2, S3 for unused resource. So from the table, we can obtain the value for X1, X3 and X2. The value for X1 is 48, X3 is 28, S2 is 36. For variables that are not listed, the value is 0. Determine the value of A. A is total profit Z. From the previous slide, the optimal solution is X1 equal to 48, X2 equal to 0, and X3 equal to 28. So to obtain the total profit, we must substitute value of X1, X2, and X3 into the objective function. So A or Z or profit is equal to RM588. Which resource is or are not fully utilized? State the value. S1, S2, and S3 represent unused resource for labor hour, machine hour, and raw material respectively. As we see, the values for S1 and S3 are 0. This shows that both labor hour and raw material have no leftover. Both resources are fully utilized, while S2 is equal 36. So it means that machine time is not fully utilized. Hours left is 36 hours. From the previous slide, we found that workers' time and raw material are fully utilized, while machine time is not fully utilized. 36 hours is left unused. From the linear programming model, we know that the total labor hour available is 360 hours, machine hour is 300 hours, and raw material is 600 kg. Thus, at the optimal level, total usage of labor hour is 360 hours, machine hour 300 available minus 36 leftover, so equal to 264 hours, and raw material is 600 kg. Shadow price is referring to maximum amount the firm should pay for every additional unit of resource to make available. Shadow price can be obtained from final simplex tables. So these are the number in the C minus Z row of slack variable column. But we ignore the negative sign. So from the final simplex table, the shadow price of labor hours is Rm 1 ringgit and 30 cents. The shadow price of machine hour is Rm 0. And the shadow price of raw material is Rm 20 cents. What does a zero shadow price mean? How could this happen? Shadow price Rm0 means that one additional unit of the resource is worth nothing. This happens because the resource is not fully utilized. In this example, optimal solution S2 is equal 36. Is it worthwhile to pay Rm2 for one additional hour of the labor? Explain. Shadow price for labor hour is Rm 1 ringgit and 30 cents. So in this case, it's not worthwhile because the maximum amount to pay is Rm 1 ringgit and 30. The second question, should the company pay Rm3 for 3 more hours of the labor? Rm3 for 3 hours. So it means that Rm 1 ringgit per hour. So it's worth because the maximum amount to pay is 1 ringgit and 30 cents. Is there any alternative optimal solutions? Why? How to check? In C minus Z row, if there is a non-basic variables equal to 0, alternative solution exists. Non-variable in the example is x2, s1 and s3. So there is no alternative solution in our example because in C minus Z row there is no non-basic variable equal to 0. What will be the new Z value if the company increase 2 hours of labor, increase 3 hours of machine time, decrease 3 kilograms of raw material? First, we have to look at the shadow price for each resources. Our old profit for our problem is Rm 588. So the first question, increase 2 hours of labor. Shadow price for labor hours is Rm 1 ringgit and 30 cents. So it means profit will increase by Rm 1 ringgit and 30 cents per additional hours of labor. So if you increase 2 hours of labor, the profit will increase by 2 times 1 ringgit and 30 cents plus 588. So your new profit will be Rm 590, 60 cents. So the second question, increase 3 hours of machine time. The shadow price for machine time is Rm 0. So it means if we increase machine time, it was nothing. So our Z is remain unchanged. The third question, decrease 3 kg of raw material. Shadow price for raw material is Rm 20 cents. So it means if you increase or decrease raw material, the profit will increase or decrease by 20 cents per kilogram. So you decrease 3 kg of raw material, the profit will decrease by 3 times 20 cents. 588 minus the decreasing, so equal to 587 and 40 cents. Module 4, the dual in the linear programming. Every linear programming primal model has a dual model. The first way of stating a linear programming is called the primal of the problem. The The second way of stating the same problem is called the dual. Step to form a dual. First step, if the primal is a maximization, the dual is minimization and vice versa. The second step, the right-hand side values of the primal constraints become the dual objective function coefficients. The third step, the primal objective function coefficients become the right-hand side values of the dual constraints. Fourth step, the transpose of the primal constraint coefficients become the dual constraint coefficients. And the final step, constraint inequality signs are reversed.